Good morning, everyone. Students, welcome back to our class. Today we are going to learn about area approximation. Today's date is 19 May 2020. So as we always do, find your book, have your pen. Can you make yourself comfortable? We are going now to continue. And when we are talking about this area approximation, or when we are learning area approximation in Form 4, remember this is the second last topic of Form 4. We did some area approximation in Form 1, where we used when we find area of irregular shapes, and we are going to continue with the same, and we are only going to see when we want to find area of regular shape, like area covered by a forest, lake, ocean, any piece of land, an island. You want to find area of this. What we are going to use is we are going to use approximation methods. There are two types: unit square of a grid, where you use a grid of 1 unit square, so that we place, then we tick the complete or the full 1 centimeter square. Then we add the other one, which we are going to do. So we are assuming that this is our grid. We have our grid in that manner. Then we have another one here. So that is our grid of 1 centimeter. So what we are going to do is to start with to count the complete 1 square centimeter. So we have 17 complete. The complete ones, complete 1 centimeter square is 17 units. Then now we take the half ones. So we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 incomplete. 1 centimeter square is 20. Now, the scale of this scale, maybe we are given 1 centimeter represents 50,000 centimeters on the ground, meaning this is the same as 1 centimeter to 0.5 kilometers. So we are going to find area of this, and this one is 17 centimeter square. So we are going to say we are going to have 17 centimeter square, and we are going to do this way. So we are going to square this. We are going to have this so that we know what is the measurement in kilometers. So it's going to be 0.5 square to get 0.25 kilometers square. So that we're going to say 17 times 0.25 we are going to get this one in kilometer square. Now this one is going to be our area. area of this of the complete. Then we are going to take half of this. We are going to take half of we are going to take half. We are going to take half of 20 to get 10 centimeters square. So that we're going to say 10 times 0.25. This one we are going to get also in kilometer square. And for this we are going to get 2.5 kilometer square covered by the incomplete part. Then this other side we are, so while this other one is going to be 4.25, so that we are going to add 4.25 plus 2.5 to get 6.75 kilometers square. That now is the area using this technique. That is one of the techniques that we are going to use. So you can have a good look at this. So find any regular shape that you have. Can you have a grid of 1 centimeter square, 1 unit square, so that you're going to tick, or you are going to count. It is a counting technique. So you just count the complete square where you have complete unit square. Then you are going to add the rest which are incomplete. Then you divide by 2. This technique is not going to give you an exact. It's going only to give you an approximation area of that irregular shape. So can you have one? Have a try? Then we'll continue. So we are proceeding with trapezium rule, and this is where we are going to have area. Let us consider this area of this area bounded by this curve and x-axis and also y-axis. So when we want to find area of this curve, then we are going to draw that curve. We are going to draw the curve. This one is y-axis, this one is x-axis, and here is our table values. When we have 0, we have 5. When we have 1, we have 5.5. When we have 2, we have 7. When we have 3, we have 9.5. When we have 4, we have 13. When we have 5, we have 17.5. So that is our table values. So we are going to draw one, 2, 3, 4, 5, 0. Then for this, as you can see, we have 17.5. Then it means we are going to have up to 20. So we can have 5, 10, 15, 20. We have 5. So we'll have 0.5, 0.5, meaning starting from here. Then we move to 1, 5.5. 1 is 5.5. 5, yeah. We move to 2, we'll have 2, we have 7, 3, we have 9.5, 4, we have 13, then we have 5 or 17.5. So remember that this is my own graph. There is no I wish we had a board with a grid. It would have been an accurate graph. So this is our graph. This is y equals to half x squared plus 5. And we want to find the area bounded by this curve between x equals to 1, and x equals to 5, from this point to this point. We want to find this area here. This is the area we are looking for. That is the area we are looking for. Remember, it is a trapezium rule. Remember, trapeziums are taking this form. That is a trapezium. And in trapezium, we always say a half times height into a plus b, where here is the height, and here is a, and here is b. So this is how it should be. That is how trapeziums are. So we are going to have trapeziums in this figure. So we are going to have these ones that way. Then we are going to join. All these using straight lines. To have trapeziums. So those are the number of. So we have A, B, C, D. We have 4 trapeziums. So I'm going to, when you now have this formula here, in each and every trapezium, we can combine all of them and have one formula of all this. But now I want to show you one thing. Here from 1 to 2, here we have height, and the height. Again, we have this one, the height from 0 to 5 is known as y1, y2, y3, y4. Those are y. So that we are going to have all of them. We are going to combine all of them and have so this is the first value of y, and we can have it as y naught. Then this one is yn, the last one. So the first one is going to be y naught, the last one is going to be yn. So don't just wonder what I'm going to write here, so that we can have area for finding this is going to be half the height, which is the same as that one. Then we have a bigger bracket. Then we multiply here. We find the sum of the first and the last. Y naught plus yn plus twice the the y, the rest in between. So we'll have y1 plus y2 plus all the way to yn minus 1. The second last one. So that is going to be our formula. So have this formula clearly. We can write it here. A clear one. It is area. Area is given by half h. We have a bigger, so we have y naught plus yn plus twice the y1 plus y2 plus all the way to yn minus 1. Then you close the bracket and you also close the bigger bracket. So that is the formula being used in trapezium rule. And we are going to have this, our height in this case, when we want to find area, we are going to say half times, the height is 1, here we have 1, then we open the bigger bracket, then we have our y1, we have here, our y naught is 5 plus the last one, which is 17.5, then we close plus twice 5.5 plus 7 plus 9.5 plus 13, then we close, and we also close the picker bracket. So you just start with this one. You find it is 22.5 plus you add this one, then you twice, then you'll now multiply by half. And what you're going to get is half into, this one is 23 actually. No, here is we have an error here. We don't have this. Here's this one. Remember it was x1. So we are starting from the height of this, which was 5.5. 5.5. But if we were asked to find from x equals 0, here is where we would have started. But now here is 5.5, so that here is twice as from 7, because we are told it is x equals to 1. Sorry for that error. This one is 1, so we are going to start with the height of where 1 is. We did an error that we started from 0 and yet it was x equals to 1. So in this case you are supposed to follow the instructions carefully, so that we have 23 plus this one is going to be 23, then addition of this is going to give you 59. So that when you add, you are going to get 41. When you divide by this one, you're going to get 82. Yes, 82. You're going to get 41 square units, because we are not given the units, so you're going to just use square units. So this is about trapezium rule. As long as you've known how to use this one, and also know how to follow the instructions, then it's so simple. If you are told to have x equals to 0 and x equals to 5, you would have started with 5 and 17.5. Then you have this 5.5 here, like we did earlier. But now, for this case, you are given as x equals to 1. So I want you to find a question on that part. Then you are going to so here is your question. Plot the graph. Plot the graph plot a graph of y equals to x squared minus 10x plus 25. So this is the graph. Y equals x squared minus 10x plus 25. And use the trapezium rule to estimate the area enclosed by the curve, the x-axis, and the line x equals to 1, and x equals to 5. Use 4 trapezium. So for this case was 1, 2, 3, 4. We have 4 trapezia. And remember that this was the curve bounded by y-axis. It is bounded by, this is the curve. Y-axis is here. X-axis is here. Also y-axis is here. And curve. And that is why we found our area as this. So you can easily find that area. You'll realize that it is also an approximation because we have some part of this graph left out, either on the other side or on the lower side. So this one is going to just give us an approximation. It is still an approximation. It is not exact. And we're going to see exact in the next topic of integration. We are going to see an exact area. So can you have this? That question, can you practice so that you know how to use this formula? Make sure that you understand that formula well. So we are moving on to mid-ordinate rule, and we are going to consider this curve where we have y equals to half x squared plus 1. And we are supposed to find the area bounded by the curve, y-axis and x-axis, and x equals to 0 and x equals to 3 using 3 strips. So for this case we are going to find the strips. There are strips that we are going to use. Just to know that for now there's something known as strips. So for this case we are going to use strips. And for the word mid, it is in the mid of the ordinates. So we are going to find the mid ordinates. So for this case, we also have h. We have our formula as h equals to y1 plus y2 plus all the way to yn minus 1. So this one is, we have h, and how to find h, our h is that we are going to say the length of the base, divided by number of strips. So for our case we have 3 strips, saying 3 strips. So we get the length of the base, we divide by the number of strips to find our own h in this case. So we're going to see how to find this y. So we are going to have a sketch of that. That is our axis, y-axis. Y-axis and x-axis here is also our origin, so that when we are going to have that table x, y, so that when we have x as 0, we'll have y as 1. 1 is going to be 1.5. When you have x as 2, it's going to be 2. No, 3. Because it's going to be 2, x squared is 4, divided by 2 is 2, then we have here as 3. X is 3, going to be 9, 4.5, 5.5. So that is our table, so that when we will have 1, 2, 3, 4. Then we'll have 1, 2, 3, 4, 5, 6. So that we have 0, 1 here. We'll have 1 and 1.5 here. We'll have 2 and 3. We have it here. We have 3. That's 5.5 here. So that we'll have our curve. So that is our curve where we have y equals to half x squared plus 1. So that is our curve. Now we want to find the area from x equals to 0 and x equals to 3. So all this is the area that we're looking for. All this is the area we're looking for. So we are going to have the ordinates. So for this case we are going to join. We are going first to join here, here. Then we have so that we will have these areas. I was doing this so that it's going to give us the accurate. It's like, yes. So we now have the ordinates. So we're going to look the mid ordinates, the middle of this, and we're going to drop to have, and here we are now going to get our y. Remember that in the previous one we were using the heights of the boundaries of every trapezia, but for this case we are on the mid of the trapezius. So you can see we have 3 strips. So we are going to have the formula. We are going to say area equals to width of the interval, which is h, multiplied by the sum of the ordinates. The sum of the ordinates. That is what we have. So we want to find when x equals 0.5, because it is the mid. When x is 0.5, what is the value of y? What is the value of y? And using this formula, what is the value of y when we have x as 0.5? So for this case, when you have x is equal to 0.5, then we are going to have our y as 1.125. When you replace x in this curve, again, when we have x as 1.5, then we have y as 2.25. See, 125. So make sure, I have already mine here, I've calculated. Make sure you also calculate yours so that you get exact as this. When x is 2.5, we have y as 4.125. So that our area for this case is going to be height, and our height is 1. So it's going to be 1 into the sum of all these, 1.125 plus 2.125 plus 4.125 to give us 7.375 square units. So as you can see, this is the mid-ordinate rule. So we are supposed to draw to have that curve, then ensure that you understand x equals to 0 to x equals to 3. You also understand the formula here, and then you proceed to find the values of y when x, because you know the x because this is the mid. So you find the excess of this, and here. Now remember that where you are looking for is when x is 0.5, then these are the points you are looking for, because where this one touches, we were on the mid, so we were constructing that line to meet this x here. So these one are the values of this. All these values here, all these three values is this one, this one, and this one. Note the positions of here. Where that mid is touching the curve, is cutting the curve. Here, here, and here. That is where you have your y, so that when you now sum all of them, you are going to get 7.375. So you can have one of the questions, so that you're going to use. You can also reduce the number of strips. You can reduce the number of strips, or you can add the number of strips and reduce the area of this. You can also add, you can say 6 strips. And the more you reduce or you increase, when you reduce the area and you increase the number of strips, the more you get closer to accuracy. Because the larger then you're going to, from here to here, there are some of the parts that you might not actually account. But when you reduce as many as possible, even 24 strips, you are going to get a closer mark, or a closer value than this one, the accurate one. So large number or many number of strips is going to give you a close figure to accurate number. So I want to give you one of the questions. So draw a graph of y equals to half x squared minus 2 from x equals to -4 to 4 equals x equals to 4, x equals to positive 4. It is x equals to -4 to x equals to 4. Estimate the area enclosed by the curve. The lines we have lines x equals to -2 2 and x equals to 4. Remember, the graph that we're going to draw in this case here is going to start from, ours started from 0 to 3. But for this case, starting from -4 all the way to +4. So if your graph is going to behave this way, then it's going to that point. So I hope you understand. What does that mean? But for this case, is x equals to -2, where you have x equals to 2 is where you're going to have, and x equals to 4. That is the area where the curve is going to be bound. And x-axis, by using the mid-coordinate rule, with 6 strips. 6 strips. So that is the question. Remember, this was 3 strips, so the other one is 6 strips.